Hi, I'm Terry Klinker. We're going to continue with our decision modeling discussion. We're going to start with an example. You now know what the properties are, you know some of the things we're looking for. So I'm going to give you an example and we're going to build through it. We've got the Flair Furniture Company. Now this is available on the handouts that you have. So let's just go through it real quick. Flair Furniture makes two products. They make tables and chairs. They have two labor pools. They have a carpentry shop and they have a paint shop. The carpentry shop has 2,400 hours available. The paint shop has 1,000 hours available. Every table requires 3 hours in the carpentry shop to build it and 2 hours to paint. Every chair requires 4 hours in the carpentry shop and 1 hour to paint. The problem we have is we want to maximize our profit margin based on this problem. The other information you need to know is the profit margin for tables is $7 each. For chairs is $5 each. So we want to maximize our total profit. Now, as I've mentioned in earlier videos, one of the biggest problems business students have is they come to me and they'll say, I'm no good at word problems. And as I've told you, you need to be good at them. So I'm going to help you get better at word problems. They're not difficult. The problem I think you have with them is you've not been explained what to do. So in approaching a problem, I want you to ask yourself 4 questions. All right? First, are we maximizing or are we minimizing? All right? We told you that in a linear program, we were going to maximize or minimize some quantity. The second one, what are we maximizing or minimizing? All right? The third question then is, what are your decision variables? What do you have the power to change? What can you change in this problem? And the fourth one then, what are our constraints? What keeps us from producing an infinite amount of product? If you answer these 4 questions, you can then go through and pretty much derive the entire problem. So let's start with this. First off, are we maximizing or minimizing? In this case, we're trying to maximize profit. It says we want to maximize profit. So what are we maximizing? We're maximizing profit. The third question is sometimes more difficult, especially as you're just learning this. All right? What are your decision variables? What can you decide? What can we decide in this problem? What do we have the power to change? Well, let's see here. We can't change the number of products that's given to us. We have 2 products, tables and chairs. We can't change the labor pool. We have carpentry shop and paint shop. We can't change how many hours are available. That is given to us. Now, if you are senior management, yeah, you can go out there and change some of these things. I could decide to make a new product. That takes us outside of the limitations of this problem. All right? You can't reconstruct the whole problem to make it different. We have to stay within this. We have 2 departments. We have 2,400 hours and 1,000 hours available. We know how long it takes. We could put in some type of big efficiency program and try to get the number of hours down per table and chair, and et cetera. But again, that's not within this. Remember we talked about one of the properties we had was certainty? These are things that are certain. They stay constant within the problem. Well, what do we have the power to decide? We have the power to decide the number of tables and the number of chairs. That's what we can decide, how many tables we make and how many chairs we make. And we want to find out how many of these we're going to make to maximize the profit. Now, when we have these 3 questions answered, we can write what is called the objective function. To write the objective function, the first thing you want to do is, what is my objective? My objective, all right, my objective is to maximize profit. How do I calculate profit? Well, profit in this case, profit is going to equal the dollars that I make from chairs. Nope, I'm going to keep them in the same order. The dollars that I make from tables plus the dollars that I make from chairs. I only have two products. So however much I make from tables plus however much I make from chairs, that's my total profit. Well, how much do I make from tables? Well, it depends on how many tables I make. I'm going to call tables x1. x1 is the number of tables I make. That's not given to you in the problem. It's up to you to decide. Number of chairs, x2. Those are my variables. These are what we call the decision variables. These are what you have power to do. For every table I make $7. So I extract the data from my word problem. I make $7 per table. I make $5 per chair. So the profit that I make from tables is going to be $7 for each one of those tables that I make. If I make 10 tables, 7 times 10, I make $70. Chairs, I'm going to make $5 for every chair, x2. If I made 100 chairs, I would make 5 times 100, I would make $500 profit. This is your objective function right here. My profit is going to equal 7x1 plus 5x2. Once we've done this, then we go, what are the constraints? What constrains us from making an infinite number of tables and chairs? Well, in this case, what do we have that constrains us? Well, let's see here. It takes us 3 hours of carpentry to make a table, and I only have 2,400 hours available. There's a constraint. It takes me 2 hours to paint a chair. I only have 1,000 hours available. So in this case, my constraints are carpentry hours available and paint hours available. Those are my constraints. All right? To figure out how to do this, how would I write my constraints in a linear fashion? How would I put this into a mathematical equation? We've already figured out how to put profit into a mathematical equation. Now we've got to figure out how to put carpentry in. Well, first off, I know that I have 2,400 hours available. This is how much is available. 2,400 hours. How much do I use? Well, I use 3 hours of carpentry to make a table. I use 4 hours of carpentry to make a chair. How many tables do I make? Well, I make x1 tables. How many chairs do I make? I make x2 tables. So it takes me, the number of hours I spend making tables is going to be 3 hours times this number of tables. 4 hours times this number of chairs. This is what I've used. That's how many hours I've used. I have 2,400 available. This is how many I've used. What's the relationship going to be? Well, the amount that I use must be less than or equal to the number that I have available. So my first constraint here is carpentry. And it says here that 3 hours for every table plus 4 hours for every chair must be less than or equal to the 2,400 hours that I have available. For paint, you should be able to do this one on your own by now, but let's walk through it. I have 1,000 hours available. It takes me 2 hours to paint a table, 1 hour to paint a chair. So for paint, 2 hours for every table I make, plus 1 hour for every chair that I make, has to be less than or equal to the 1,000 hours that I have available. We've now extracted everything out we need to solve for this. Need to do one more definition for you, though. When I have this equation, notice I said that I had 3x1 plus 4 hours for every chair, less than or equal to 2,400. This is what's available. This is what's used. We call this the right-hand side of the equation. We call this the left-hand side of the equation. The left-hand side of the equation must contain all decision variables with a single coefficient. Each of my decision variables has a single coefficient in front of it. The right-hand side has a simple number, no decision variables. On my left-hand side, all of my decision variables must be raised to the power of 1. It's a linear equation. No square roots, nothing in the denominator. That's to the power of -1. So this is what we call the proper form of a linear equation. From this, we can tell what we're doing. This, again, tells me what's available. This tells me what I've consumed. And I can use this relationship in a linear program to determine whether I have met my constraints or not. In the next section, we'll show you how to graph this and come up with a graphic solution.